Greetings, Geometry Advanced Scholars. This is Mrs. G, and we have kind of a unique couple days, and we are going to actually go through your first geometry lesson of the year. I'm actually going to do through video because of finishing up our stats test and an off-campus learning day. So today we're going to do quite a bit of stuff. Probably this lesson, if we had normal days of school, would be split into 2 lessons. So we're kind of going to split the same way. So day 1 is going to be just take the notes. There's no homework, just take the notes. Day 2 is actually going to be doing the homework assignment. So that's going to be your off-campus learning day. But stats is done. I'm in the process of grading those tests. And then you will be able to go ahead and do the homework. Now, what's really unique this year is we no longer have a textbook. So taking notes is going to be extra important so you understand where all that information is coming from. So I just want to make sure you know that, that you guys are able to understand. And now, you know, in statistics, a lot of you learned that if you don't know your vocabulary, you're not going to understand. In geometry, it's the same way. If you do not learn the correct notation and the vocabulary, you're not going to be able to do it. I'll tell you right now, the math is not hard in geometry. What's hard in geometry is using correct notation so you're communicating what you want to communicate. So today is mostly definitions and then mostly just notation. So a lot of stuff that you've heard before, but you were never held to a standard that you are going to be held now. So here's the cool thing. You are studying geometry, okay? So geometry is also called Euclidean geometry. Euclid was a famous Greek and Roman philosopher, so just go way back in time, who actually wrote the very first textbook. And all math textbooks are built upon this. All math concepts are really built on the same way. And all geometries, and by the way, there's thousands of geometries out there. We're studying Euclidean geometry, which is, I call it the geometry that we use every day. Okay, this is the math that helps us measure, help us build things, that type of thing. But all geometries start the same way. We start with undefined terms, terms that just you need to know, they're just understood. I'll give you some fun examples of this. An undefined term, when I say blue, every single one of you know, and you can point to something in the room that's blue. Now, here's my question. Whoever decided blue was blue? Are you with me on that? Someone decided the color blue was blue, and then we've used that to define blue ever since. So that would be an undefined term. Now, so that's an example of an undefined term. So like we just said blue. Now, a defined term that you would all know that we could talk about would be blue jeans. We know that jeans are a pair of clothing with 2 legs that we wear, and they're most of the time they're the color what? Blue. So blue jeans. They're very definable, concrete, no question what they are. Then we build off of what are called postulates. And postulates are just rules that can't be proven. And we're going to define that again. Let me give you a silly example of a rule that can't be proven. But now this is actually, I won't even say silly. I'm going to take that back. An example of this is our Christian faith. Now, I always ask people, what is a rule that can't be proven in the Christian faith? Or what is a belief in our Christian faith that we can't believe and we got to be able to do? And a lot of people say Jesus died on the cross. People say you could probably, because of historians and stuff like that, you could prove that. Here is the basic postulate, the beginning belief of all Christianity. God is real. That would be a postulate. Not provable, God is real. Now, I believe what the Bible says, that you can see God through creation, through his image and the people he created. But if you really talked about just the basic belief, we believe that God is real. Okay, theorems. These are rules that are provable. Rules that are provable. And this is what your parents get all mad about because of provable things. They had to do a lot of these and they hated it. Now you're going to have to prove stuff well, but don't worry, we ease into it and I help you. I don't make you miserable doing it, but you do have to know why. And you can't prove anything unless you know your definitions, your postulates, and your theorems. So huge that we use correct notation. So we're going to start with, and almost be hypocritical on it, we're going to start with undefined terms that most of you already know. Okay, so this is undefined. I'm going to try to define them and explain to you correct notation. The very smallest thing, the utmost thing that we use in geometry is a point. Now, a lot of you don't know the definition of a point. Now, understand a point names a location and has no size. Now, notation-wise, we represent it with a dot, okay? So you see over here in the diagram column, which I think you can see my cursor going, notice we have 5 dots. What do they have next to them? A capital letter. Every one of those capital letters represent a point because that's a location. So when we look at this and I see the capital letter here, I'm going to go, oh, that's point A. Now, to save time writing, we don't want to write the word point out all the time. So you're going to see point A like this. Now, correct notation is, if you just say the letter A, yeah, it means the letter A. Or maybe it's a fancy variable. But the moment you put the word PT in front of it, you are naming a point. And you guys know I'm referring to that point. Now, what if I do the following? Point D. All right, you instantly know I'm talking about that point. Now, the rule is when you look at a point or you label it on a graph, you put a point on there, you have to use a capital letter. And when you name it, you have to put the PT in front of it. And if I want to label many of them, you just go PTS for points, and then you just list them. A, B, C, D, and E with commas in between to designate their point. So what is the key thing for the notation of points? You must use capital letters. If you choose to use, can't make letter look like a word here, guys. Letters, all right? If you don't use capital letters to label a point on when a point is drawn or to name it, you will have it wrong. I will physically count it wrong because you didn't use correct notation. Now, the next thing we use is space. Now, space is something you kind of all instinctively know. I always tell the people who are Star Wars, it's the Force. It's everything, okay? Space are all points that exist. So that means everything. So think of the smallest thing you can think about, and then now think of it even smaller, and then realize everything's made up of that. So in geometry world, we're not talking biology world, real world, everyone is just a bunch of locations and a bunch of points. So you just exist. The air you breathe is just points. So that's a very much space. It just includes everything. So I always tell people that includes the earth, that clears the universe, it goes past that. It just includes absolutely everything in it. There is no notation for it because there's an infinite number of points, because I can always add another point and get more points. So just know it exists and it includes everything. Then we have our next one, a line. And if I told you to draw a line over here in the diagram column, all of you would go like this. Then I would say that's not a line, because a line has to go on forever. So we add the arrows to it. So when we think of a line, we think of this. First of all, we always think of something that's straight, okay? So it's a straight path that has no thickness and extends forever, okay? So has no thickness and extends forever. It never bends. This is huge. It never bends. There's no curve to a line. Now, when you are working with lines, what type of notation that we use? First of all, you use any 2 points on the line. So here's what I mean by this, okay? So here I have a line, and if I have these 2 points, and I call it X and Y, and we're using capital letters because points are used with what? Capital letters. You would name this line X, Y. Now, I just use those. Who said X had to go first? It doesn't. You can choose either one. It's kind of like connect the points. Or you could call that line y, x. So you can use any 2 points. What if there's more points than 2 points? Great, just pick any two, because I understand when I see the line symbol above, directly above, I know that I'm connecting those 2 points and I'm going forever. I'm putting a line between them. Now, that is one. Or you use a lowercase, kind of like italicized letter. And then you write the word line in front. So with the same diagram, a lot of times they'll use a lowercase cursive L. So it's lowercase and cursive. And they will write it like this. Line L. Notice the word out in front is line. That has to be used. If you just said this, I'd be going, what are you talking about? What variable? Why are you looking at variable L? But the moment you write the word line in front of it, I look over here and I see the lowercase l, and I'm like, oh, that represents this line. So lines are going to be really huge. We use them a lot in here. All right, then our last kind of undefined terms, and then we make it really easy on ourselves. Our next one is called a plane. What's a plane? And notice not an airplane, not what we're working with. We're talking about a flat surface. So a plane is just that, a flat surface that has no thickness and extends forever. Right? Now, what do I mean by this? Okay, first of all, an example of this would be like a flat floor, because that way we don't trip and fall. So think of it like a floor that's flat, and then a plane just keeps going forever. So like if you have the floor in your room, it keeps on going to the next room and the next rooms, and eventually it goes outside and it gets bigger and bigger. But again, it never ever bends, okay? So it's not like a piece of paper that you can just bend in half. It's always going to stay flat. Now, because we're trying to show on a two-dimensional piece of paper, which is flat, that's a plane, you show planes when you draw them as like these parallelograms. So it looks like you kind of have a dimension of it coming out at you. So one of these that you're going to use is the following. You're going to use points to name a plane. So you're going to use, make sure I spell it right, use 3, and you try to use non-collinear points to name the plane. So when I look at this, you have to write the word plane. Everyone listen to me. You have to write the word plane. If you just list points, it makes no difference. But if I sit there and said plane A, B, C, notice no commas this time. You know that A, B, and C all lie in that exact same flat surface. Now, you could shoot it in a different order. You could be plane CAB. It doesn't matter the order, long as I know they're in the same plane, I know they're in the same flat surface. Please do not name 3 points that are on a line, okay? And you'll see why at the end of the lesson not to do that. Now, you can do it one other way, or use one fancy letter given. All right, so we're going to use one fancy letter given. What I mean by that is, notice off to the side here, we have a single kind of italicized letter R, but there's no physical points next to it. So we could also call this plane R. Now, the other thing is, you can use more than 3 points. If there's more points on that flat surface, you can use more than 3 points. So really, we should say use at least 3 non-collinear points. And again, they have to be capital letters or they don't work, because if we're using points, stuff has to be with capital letters. Okay, so that's your undefined terms. Everything basically from here on out is always going to be defined. All right, our very first term, and this one always gets me when people don't get it. It says collinear points. Guys, those of you who had root words training, what's the root word right here? Linear. Oh, it means line, okay? So what are collinear points? Points which lie on the same line. So points that lie on the same line. So, okay, over here we have our line T, okay? And I know it looks a little funky over here. I'm going to get rid of that for a moment. retry. All right, so line T. All right, now with line T, I want points that lie on the same line. When you're naming collinear points, you need to name more than 2. The reason why you need to name more than 2, you'll again find out towards the end of this lesson, but you're just going to sit there and say points here, and let's look at our diagram over here. If I'm doing collinear, would you agree with me I could just go GHI? So points G, H, and I. So when you name collinear points, think 3 or more, because 2 are always going to be on the same line. So pretty simple. Now someone goes, can I pick different ones? Yes. You could go HIJ or JIG or anything, long as they're on the same line. All right, now the next one. Look how simple this is. Non-collinear points. So it says points which do not lie on the same line, okay? Points which do not lie on the same line. And my friend, you must name 3 points or you will get this wrong. Because again, I told you 2 will always be collinear, but you must name 3 points. Now, to do this, name 2 points that are collinear. Any 2 points that you know are collinear. So let's say I did something like HI. So I go here, points. Over here, my diagram still to the right that we're using. Points, I'm going to go GH. Notice those 2 are collinear. But to be non-collinear, I take a point F and I name it off. And notice you make like a triangle, which is a huge thing. So anytime you kind of make a triangle, it's going to be non-collinear. Another example of this could be something like this. Points, how about H, J, K? So H, J, and K. Notice all 3 of them are not on a line. So you have to name at least 3 to be non-collinear points. All right, we're going to keep on going. I'm going to try to book through these. Now, the next one is a very simple word. It is coplanar. Coplanar means with the same plane. Those are points, lines, other types of figures that you're going to work with, which lie on the same plane. All right, so we're going to use diagram W to give an example for this, okay? So diagram W here is this lovely plane that I drew. I know you're overwhelmed with my awesomeness here. And I want to know, let's just say, points that are coplanar, okay? So when I look at this, all 4 of these points, if you look at them, are they all lying on the same plane? Yes. So we would just say, oh, that's points A, B, D, and C. Those are all coplanar. Now, another example of coplanar you could use would be something like this. Point A, which is this point, oops, actually let's do point B. I'm changing my mind on that one. Point B and line AD are coplanar. Notice AD, I did my 2 points. I'm talking about line AD. There's my line. But point B is still on that same flat surface. So they are going to be coplanar. So point B and line AD are also considered coplanar. Now, we're going to talk about non-coplanar, which means points or lines or things that are not on the same what? Exactly, that are not on the same plane, which do not lie on the same plane. So let me give you an example of this. So one thing you need to know, for non-coplanar, let's do this in blue. I'm going to change it here. You must name more than 3 points to describe non-collinear points. Here's why. 3 points are going to be on a plane, period. Again, explained later. But looking at this diagram, Z, this is name 4 non-coplanar points. So here's how you name it. If I want 4 non-coplanar points, put 3 on the same plane. Now, these are 2 planes that are intersecting. When you see a dot line, that means it's coming at a different angle and you can't see it because the other one's blocking it. So we notice we have a plane N here and a plane T. So it says name 4 coplanar points. So here's what I'm going to do. I'm going to name points B, A, C because they're all in the purple plane N. So we're going to say points B, A, C. Then I need a point that's not on there. Well, the only point not on there is E. So we go points B, A, C, and E. Now, someone goes, what about point D? Point D is coplanar with B, A, C, and D. They're all in that blue plane, so they lie in the same plane. If you didn't use E, you weren't going to be able to get non-coplanar. Okay, now let's see if we can do all of this that we've talked about. And this is the type of stuff you'd actually see on your first geometry quiz. We're going to look at this diagram up here, and if this is really hard, just know that's supposed to be like a line T cursive there. It says, refer to diagram A above. Name line T in at least 3 different ways. If I've already named it as line T, you may not use that, okay? So line T, which one are they talking about? Oh, they're talking about this line. Okay, how do we name lines if they already use the lowercase letter? Any 2 points. No more than 2 points. Let me iterate this. Only 2 points. So when we're doing that, you're going to do something like the following. Pick 2. Oh, I like GH. Great. Line GH. I can name it differently though. How about if I liked line IH? Great. I and H are on the same line. Or you could do line HI. Or how about line GJ? Notice every single one of these, though, have a line symbol on top of them, and you put them right next to each other. Now, it says name line T in at least 3 different ways. Well, I have 1, 2, 3. How many did we just come up with? I mean, there's probably more. 4. So you only need to have 3 of them, but these all work for line T. Now, next one says name 4 collinear points. Well, that's easy. Name the 4 points on the same line. So make sure you put your PTS down and you get G, H, I, and J. Awesome. Then it says identify 3 non-collinear points. So when you're doing 3 non-collinear points, pick 2 that are on the line. Great. I'm going to use H and I. All right. If I'm looking at H and I, they're on the same line, correct? So what am I going to pick? Either F or K then. So points like HIK. Now, the hint is name any 2 points on the line and then 1 point off to be non-collinear. The next one says draw 4 coplanar points A, B, C, and D in plane W. So remember to draw a plane. You could just do a rectangle if you wanted to, but I'm making my plane look like it's coming out at us. You can sit there and put, as long as you put points here, label them with your capital letters here, A, B, C, and D. Someone goes, did I have to go to those spots? No. Put your 4 points anywhere in there and label them. Capital A, capital B, capital C, capital D. And then if I'm looking at W, I want to have my W cursive or somewhat in that left corner to make it really easy. But notice I didn't put a point next to it because I didn't want it to be confused. All right, we've just gotten through about halfway through our notes. I think, would I say halfway through our notes? Yeah, we're still going to have to book, guys. I hope you don't mind. But a lot of this is huge. We'll iterate it and learn it. Next one, we're going to keep using defined terms. We're going to do some more of them that you're supposed to know. And again, you've seen these before, but teachers probably haven't held you to the high standard of notation. First one, line segment is part of a line consisting of 2 endpoints and all points between them. Okay, so let me give you an example of this. This would be considered a line segment. Notice no arrows. And we have our ends. We have a beginning and an end. So that is named line segment AB or segment BA. So we literally go line segment AB or line segment BA. It doesn't matter which one goes first, but you name a line segment by its endpoints. Name by endpoints. Now, someone goes, what's an endpoint? Here's the easy thing to think about. An endpoint is just a point at the end of a segment or the starting point of a ray. Now someone goes, oh my God, what's this starting part of array? Don't worry about that yet. But here's just another silly example we can use. Actually, let's do it this way. Why be the same? Here's C, here's D. So points C and D are endpoints, because I start and end, okay? A line does not have endpoints because lines go on forever, but a line segment is a finite measurable thing where we have endpoints. Okay, the next one, we're using a array, okay? Array, I'm gonna use a different color here. A array is a part of a line that starts at an endpoint, a single endpoint, and extends forever in one direction. Okay, let me give you an example of this. I'm going to have an array. I'm going to have an endpoint, and then it extends forever in that direction. And this one I would call RS. So this would be array RS. Must name endpoint first. When you name array, you never worry about the arrow going in an opposite direction, okay? When you name array, you just go endpoint, and then you name a point going in the direction you're going. So like I have my endpoint R, and then I'm going in the direction of S, and you all know where I'm going with it, and you just put the arrow going one way. Now, what if I have an array that looks something like this? Here's my value. This is C. I'm going to say that's D, point D. Do I name it array DC? No. You must name the endpoint first. So the correct way of doing that is I still draw my arrow to the right. I just name C first, and then I'm going in the direction of D. Start at C, go to D. When you see array. Now, remember, we've used line, segment, line, and array symbols. Those symbols dictate how you name things. All right, the next one, I'll tell you right now, hint, hint, is going to be on your quiz coming up, okay? So when you have on the quiz, it's going to be there. So on this one, what are opposite rays? There are two rays that have a common endpoint and form a line. They will never overlap. Overlap. Here's what I mean. Let's go green, pretty color. I'm going to draw a line. I'm going to put a point right here. We're going to call this one X. This point is Y, and this point is W. Do you guys agree with me that points W, X, and Y are collinear? They're all on the same line. But what makes opposite rays? Opposite rays are going to be ray XW and ray XY. They're opposite because what endpoint do they both have? X. One of the rays is going to the right, right? And the other ray is going to the left. Notice notation though, when I write down notation, endpoint first, the point in the direction you're going next. Key ones, guys, I'm going to ask a lot about rays. I'm going to ask a lot about line segments, so making sure that you know that notation. All right, so we're going to draw and label stuff to see if we understand what that means. So like on the very first one, it says, draw and label each of the following. A segment with endpoints R and S. So here's all you have to do. Here's a line segment, beginning and end. Here's R, here's S. Woo! So hard. All right, next one. Says, notice it's over here with the line segment with one arrow, so it's array. Says, draw ray AB, which means my beginning point, my end point is A, and then I just got to go some direction with B. Guys, I could have gone a lot of different directions with that. I just chose to go to the right because I'm right-handed. So that would be ray AB. It says, draw and label each of the following opposite rays with a common endpoint Q. So when you're doing this one, this is where it gets really easy. Draw just a line. Put Q in the middle of your diagram. Notice I didn't say in the middle of the line because lines don't have middles. And then just pick points. Oh, let's use A and B. A and B. Because remember, opposite rays will make a line, so they're going to be formed, and there's no overlap. So what are our two rays? Well, you have to use Q as your endpoint. So it would be ray QA and ray QB. Those are opposite rays. All right, we are almost done, guys. We're cranking this out. My goal is to get this video under 20 minutes, and we might be able to get this under 45. Go team, go. Okay, now with this, my friends, we are going to use now postulates. So we started with undefined terms, then we've had defined terms. Now we're going to postulate. Another word in some geometry books, a postulate is also known as an axiom. It is just a statement that is accepted as true without proof. Guys, like again, this would be what Christians would go, we believe God is real. The other axiom of our postulate of our faith would be Jesus Christ is God's son. Simple as that. So we keep it really well. Now, here's the thing. Sometimes our postulates or theorems will have names. If they have names, memorize this concept with the name. If it doesn't have a name, you just have to memorize the statement with it. Now, these are the very beginning postulates, the very beginning truths that happened with Euclid. This is how he started his geometry. They are not hard, and some of you are just going to go, postulates are always common sense. And my answer is yes, because they just are. Like, you're like, of course that's going to happen. And that's how I need you to think about these. All right, our first postulate. So I just put post 1 there. Our first postulate is the following. Through any 2 points, there is exactly one line. Is exactly one line. Let me explain this. Draw 2 points in here. I'm going to put one here. I'm going to put one over here. And I'm going to label them X, Y because I'm just not that exciting. So here's point X and point Y. I'm going to draw a line between them. Okay? Now here's my question. Can I draw a different line between those 2 points than the one I've already drawn? And the answer is no. No matter, I can't because lines don't bend, right? So if I draw a line through there and line straight, I can't change that. Now, do you guys know what's a real life application of this? When you cut across grass when you're trying to get somewhere, that's the idea of the shortest distance between 2 points is a straight line. So this is what makes lines straight. Because if they weren't straight, could I draw multiple ones in? Yes. Okay, so that's the first postulate. Next postulate that we're going to go. Through any three non-collinear points, there's exactly one plane containing them. Or you could also say this, another example of wording this, through any 3 non-collinear points, there's exactly one plane. So here's what I mean. Look at this. I'm going to put a point here, A, point B, and point C. So there is a non-collinear point. Do you agree with me? I can just draw this parallelogram that contains all 3. Right. Here's the hint. Are you guys ready for this? The hint. If you can make a triangle, you make a plane. Now, what's a real life example of this? Real life examples of this that are used all the time are tripods. Tripods allow you to go on uneven surfaces or ground by putting the three braces down, and it will always create a flat surface. This is the reason why I always tell you don't lean back in your chairs, because when you're leaning back in your chairs, you're just focused, you're literally leaning back on 2 points, which is like you're balancing on a line. But if all 4 legs of your chair are on the ground, you're on a flat plane. It's less dangerous. Okay, now here's another one that I think is so common sense. You guys are going to go, Gregerson, so common sense. This is why they're postulates. They're just true. Here's another one. If 2 points line a plane, then the line containing them lies in the plane. Now, let's draw a plane here. I'm just going to do a simple one. Here's my 2 points. I'm going to do, here's X, here's Y again. Guys, they're on the same plane. Oh, let's call that plane. Let's do a pretty B, cursive B there, plane B. If I draw my line, because there's only one that exists between those two, where did that line end up on? Beautiful. They ended up on that plane. Common sense, anyone? When you have a flat piece of paper and you put 2 points on that paper and you draw a line between those 2 points, is that line on that paper? Exactly. Exactly. All right, now a new definition. We have so many new definitions and postulates. Is anyone's brains just like, oh? We have what's called an intersection. Now, an intersection, a lot of people think of this as like when 2 roads intersect or 2 paths intersect. That's actually kind of common sense way of thinking about it. But here's a geometry terms for this. It is the set of all points that 2 or more figures have in common. Okay, so it's where 2 things in geometry world hit. And we have 2 postulates based off of those values. Okay, so what is the first postulate? Postulate number 4. It says the following. If 2 lines intersect, then they intersect at exactly 1 point. So lines, if they intersect at exactly 1 point. Here's what I mean. Here's a line. I call that one line L. There's line N. They intersect right there. That's a what? Point. So point P is the intersection. Now, guys, is there any way, if I redraw these, that I could get more than one intersection between the 2? Someone goes, yeah, go like this. I'll make sure I draw a little bit better. There and there. Friends, are those lines? No, those are curves. So therefore, it wouldn't work. Straight lines prevent them from intersecting more than one time. In fact, you don't have to intersect at all. All right, last one, and then we just do a couple examples, and then you have your homework. The homework is just a worksheet. That's going to be the case this year in this class because we don't have a textbook. So your notes need to be very close to you while you're doing your homework. That's one reason why we do them on paper, and you're supposed to be putting them in a binder. For your geometry test, just so you know, in a few weeks, about 3 weeks when we take it, you need to have a 3-ring binder with all your stats notes and all your geometry notes in it and organized, okay? So there will be a grade on it, just so you know. All right, last postulate, postulate 5. If 2 planes intersect, so 2 flat surfaces intersecting, then they intersect in exactly 1 line. Intersect at exactly 1 line. All right. The one I think about this, I always think of where 2 walls intersect. And we call that a corner. But when you look at it, if you took a pen and you just drew down right the intersection, you'd create a line. Yeah, it's kind of cool. So here's how you draw something like this. And it's hard, but let me give you an idea. So we're going to draw a parallelogram. Looks something like this. So this rectangle. Now, actually, let's draw a different rectangle. Because like Gregor said, I'm trying to follow your notes and you messed it up. All right, let's draw a rectangle that we all can do really easily. Just a nice rectangle, okay? And then we're going to draw a plane that's intersecting it. And we're going to do another one, but we're going to draw this one out this way, okay? And what's really annoying is we want to show it, and we want to show where it intersects. But we want to show that this plane can keep going, but you can't see it. So they use these things, these little dashed lines, in order to do that. In fact, I'm going to sit there and I'm going to erase this one for a second. And we're going to draw it like this. So you see the dashed line and then you see the solid line. And that's almost like a pinwheel type idea. But you can see that they will only intersect at one line. They're not going to intersect at a single point, but you're going to be at one line. Okay, now, always learn the postulates or statements and theorems. I will never ask for a postulate by name. I'm not going to go, hey, what's postulate number 1? Guys, you will learn about 100 postulates this year. I'm not going to ask you postulate numbers. I just want to know, I'll say something like, hey, any 2 points will determine a unique what? Line. Or through any 2 points, I could draw a line, stuff like that. So let's use this diagram and see if we can answer some of the questions again. So we're looking at diagram Z again, and it says the following. Identify the intersection of, notice the arrows on top, line BD, so this line right here, and line AC, this one. Guys, where do they intersect? 2 lines intersect at a what? Point, which would be point what? Point C. Good job. Now, we have our 2 planes, okay? So we have our plane T, which is right here, and we have our plane N, which is the vertical one, and they're intersecting each other. Where do 2 planes intersect? The postulate tells me if 2 planes intersect, they intersect in exactly one line. So what is going to be that line? It's going to be this line, correct? Because it's coming down both ways. So how are we going to name it? Name 2 points on that line. I'm just going to go line BD because you say line CD or line BC. Yes, because the line extends forever. We know that would be the case. All right, now the next one, it says, sketch 2 coplanar lines R and S intersecting at point P. Well, we can easily do that. We got to be coplanar, so we're going to make a rectangle. And then we're going to go, here's line R. And then we're going to go, this is line S, and then we do a capital letter at point P. My capital letter does not look very capital, but we're going to get it right there. All right, my friends, got it done in 44 minutes here. But notation is going to be huge. Please have your notes right next to you and do the best that you can on the homework. Off-campus learning day is just to do the homework. Tonight's homework is just to do the notes. I will ask to look at it Monday in class. Have a great weekend.